Welcome to Science, to Sleep By, where the vast universe becomes your bedtime story. Here, we drift beyond the noise of the day, into the quiet language of the cosmos where every whisper of starlight tells a tale of time, energy, and motion. Tonight, we explore one of the most hypnotic mysteries of existence, a question as old as the stars themselves. Why is everything in the universe spinning? From the slow, steady turn of our Earth beneath your feet to the dizzying whirl of galaxies millions of light years away, everything everywhere is caught in motion. Stars, planets, atoms, even the tiniest particles known to physics, all carry the same cosmic rhythm. But where did this universal spin begin? Why does the cosmos never stand still? And what secret connection ties your heartbeat to the spin of the stars? So take a deep breath. Let your thoughts float. And as your mind begins to drift among the stars, let's uncover the secret behind the great spinning dance of the universe. Imagine the universe as an infinite ocean of silence, a sea of stars suspended in an endless expanse of night. If you could float there, weightless and still, gazing in every direction, you would notice something extraordinary. Nothing is truly still. Every star, every planet, every grain of cosmic dust, even the tiniest atom humming within your own body, is moving. Some motions are graceful and slow, like a galaxy curling its spiral arms over billions of years. Others are swift and invisible, like electrons spinning in quantum shadows. Yet all of them share a secret rhythm, a universal dance of motion that binds everything together. This motion is not random. It is elegant, ordered, and ancient. From the moment the universe burst into existence, the seeds of spin were sown. Every rotation, every orbit, every swirl of cosmic gas and dust began with the same silent pulse. The stars themselves seem to breathe in time with this cosmic tempo, each turning endlessly through space, carried by invisible threads of momentum woven into the fabric of existence. If you could listen closely enough, the universe would not be silent. It would hum a deep, low vibration of countless rotations overlapping, the music of movement echoing through eternity. Think about our own Earth. Every second, it spins gently beneath your feet, completing a full rotation in 24 hours. That spin gives rise to day and night, the dance between light and shadow that governs every life on this planet. Yet the Earth's rotation is only one step in a far greater waltz. Our planet also orbits the Sun, which itself spins and hurtles around the center of the Milky Way galaxy. That galaxy, too, rotates within a vast cluster of other galaxies, each spiraling in their own cosmic motion. Even the cluster drifts through space, carried by gravitational tides that stretch across billions of light years. From the smallest spinning particle to the grandest galactic swirl, motion is everywhere, layered upon itself in a never-ending hierarchy of rotation. There is something profoundly peaceful about this universal motion. It reminds us that stillness, in its truest form, doesn't exist. Even when you lie quietly closed, your body is moving. Your blood flows, your heart beats, the earth turns, the stars shift. Motion is life. It is the rhythm of creation itself. When we look up at the night sky, we are not gazing at distant, frozen lights. We are witnessing an infinite ballet in progress, a choreography written into the laws of physics long before the first stars ever formed. In the depths of that cosmic motion, there is symmetry, and in that symmetry, there is purpose. The spiral arms of galaxies are shaped by spin, the same pattern echoed in hurricanes, seashells, and even the twist of DNA within every living cell. The universe repeats its favorite forms over and over, from the vast to the microscopic, as though reminding us that everything is connected. The same geometry that sculpts the Milky Way also lives within you. The turn of the planet mirrors the rotation of electrons. The curvature of space-time bends in harmony with the arcs of light and the whirling of atoms. Everything moves, because everything belongs to the same grand design. But how do we know that this motion is real, that it is more than illusion? Astronomers have watched the heavens for centuries, measuring the slow turning of stars and planets, the spin of neutron stars so fast they flash like cosmic lighthouses, the graceful rotation of galaxies seen through telescopes that pierce the deep past. In those spiraling forms lies evidence of an ancient, unstoppable truth. Rotation is fundamental. It is not a detail of the universe, it is its nature. Without spin, the universe would collapse into chaos. It is spin that shapes, stabilizes, and sustains everything we know. There is also something deeply emotional about this motion. The universe spins not out of chaos, but out of balance. Every rotation is an act of equilibrium, negotiation between forces, gravity pulling inward, momentum carrying outward. That harmony between opposing energies creates beauty. The same laws that make a skater twirl gracefully on ice are at work in the whirling of galaxies. The balance between tension and release, pull and push, gives rise to form, and form gives rise to existence. When we think about the universe spinning, we are really thinking about the universe holding itself together through balance and grace. Even time, in its mysterious flow, seems to move in rhythm with this cosmic spin. The turning of planets defines our days, the orbit of Earth defines our years, and the slow drift of galaxies defines the ages of the cosmos. Rotation gives time its heartbeat. Without motion, there would be no before or after, no dawn or dusk. Time itself might cease to have meaning. The spin of the universe does not just occupy time, it creates it, sustaining the rhythm that allows everything to unfold. As you breathe slowly, as your heartbeat settles, imagine the vastness of space stretching out beyond your closed eyes. Feel the earth turning beneath you, its rotation gentle and steady, carrying you through the night. Above you, the moon circles us, drawn by gravity's embrace. Beyond that, planets spin, stars rotate, galaxies swirl, each obeying the same ancient rule. The cosmos moves in infinite layers, each turn echoing the next, a symphony of spinning motion that never ends. This is the cosmic dance of motion, the quiet truth that connects every atom, every planet, every being that has ever existed. It is the pulse of the universe, the rhythm that began when time itself began. The stars you see tonight are not still. They are dancing, spinning through eternity, carried by the same mysterious force that turns your world and whispers through your dreams. To understand why everything in the universe spins, we must return to the very beginning, to a time before galaxies, before stars, before even space itself had stretched into being. More than 13 billion years ago, the universe was nothing like the vast cosmic ocean we see today. It was smaller than an atom, denser than imagination, and hotter than any fire ever known. Then, in a moment that would define everything that followed, it expanded not into space, but creating space itself. This event, the Big Bang, was not an explosion in the traditional sense. It was an eruption of existence, the sudden unfolding of energy and time from a single, timeless point. When that first burst of energy rippled outward, it wasn't perfectly smooth. Tiny imperfections existed, small fluctuations in density, areas where energy gathered slightly more or less than in neighboring regions. These slight irregularities were the seeds of everything to come. Within them, the universe began to spin, not yet in the form of stars or planets, but as twisting currents of primordial matter, swirling like faint eddies in a newly forming sea. Those infinitesimal differences gave rise to motion, and motion became the language of the cosmos. In those first fractions of a second, energy and matter were inseparable. The entire universe was a plasma of particles, colliding and scattering in all directions. As this cosmic soup expanded, it began to cool, and the first patterns of rotation emerged. Quantum fluctuations, minute ripples in the early energy field became amplified by gravity's growing influence. Regions with a little more mass pulled more strongly, and as they drew in surrounding material, they began to twist. This was the universe's first spin, a whisper of motion that would one day become galaxies, solar systems, and the very rotation of the world you stand on now. The law guiding this motion is one of the universe's simplest and most sacred: the conservation of angular momentum. Whenever an object contracts, its rotation speeds up. You can see this on Earth when an ice skater draws in their arms and spins faster. The same law applies to everything in the universe, from collapsing stars to clouds of interstellar gas. In those early ages, as pockets of matter began to cool and clump together, they conserved their angular momentum, spinning faster as they shrank. Every star's birth, every planet's formation, every galactic rotation traces back to this ancient rule. Born in the aftermath of the Big Bang, it is almost poetic to imagine that the universe itself began with a kind of twirl, not a chaotic tumble, but a graceful, inevitable motion born from imbalance. Without perfect symmetry, there can be no movement, and the early universe was beautifully imperfect. That imperfection created flow, and that flow became spin. It's a reminder that perfection, while serene, is lifeless. It is the unevenness of the cosmos that allows creation to unfold. A ripple here, a dense patch there, a twist forming in the vast sea of nothingness. And soon, the universe was not just expanding, but rotating within itself. Billions of tiny vortices giving rise to the first structure. As time passed, matter began to separate from radiation, and the early universe became transparent. Gravity continued its work, pulling particles together to form immense clouds of hydrogen and helium, the raw materials of stars. Each of these clouds carried with it the faint fingerprint of that primordial spin. As they collapsed under their own weight, their rotation increased, flattening them into disks. In the hearts of those disks, the first stars ignited. Around them, leftover material began to clump into smaller spinning bodies, the first planets, moons, and asteroids. The entire cosmic architecture we see today was sculpted by that original motion set in place at the dawn of time. Even galaxies themselves, those grand spirals that fill the night sky, they're formed to this inherited spin. In the early universe, as regions of matter gathered into immense halos of dark matter and gas, each region had its own angular momentum. When the gas cooled and settled, it didn't collapse straight inward. It spun, flattening into a disk, a cosmic whirlpool that would eventually form billions of stars. The Milky Way, Andromeda, and every spiral galaxy you can see through a telescope are descendants of that first cosmic twist. Their graceful arms are frozen echoes of motion that began when the universe was young. But the story of spin isn't just a matter of physics. It's a matter of identity. Spin defines what things become. A star's rotation determines how it burns, how it sheds its light, how it will die. A planet's spin shapes its weather, its seasons, even its habitability. The Earth's tilt and rotation give rise to day and night, to climate, to the very rhythm of life. Without spin, the cosmos would be static, a motionless expanse of dust and gas. It is the presence of angular momentum born in that first cosmic breath that gives the universe its pulse. Scientists have spent decades studying this ancient rotation. Using microwave telescopes, they've mapped the faint afterglow of the Big Bang, the cosmic microwave background, and within that faint light, they've found subtle patterns. Those ripples are the fossilized imprints of the first motions in the universe, the tiny swirls that would later grow into galaxies and stars. They tell us that spin is not an accident. It's woven into the very foundation of existence. To think that every rotation we observe, from the turning of our Earth to the spinning of black holes at the centers of galaxies, can trace its ancestry back to those first cosmic fluctuations, is humbling. The universe began as motion. It was born in movement, sculpted by imbalance, and carried forward by laws that have never been broken. Somewhere in that first moment, when time itself began to flow, the universe began to twirl. This ancient spin has never ceased. It echoes across every atom, every planet, every corner of creation, an invisible inheritance from the universe's first breath. Every turn of the Earth, every orbit of the moon, every spiral of the galaxies, all are whispers of that beginning, reminders that even from chaos, motion finds order, and from energy, the dance of spin was born. Gravity is the quiet sculptor of the universe, the invisible hand that shapes stars, planets, and galaxies out of clouds of cosmic dust. It is not loud or violent in its essence, though its effects can be seen in the most powerful phenomena across space. Instead, gravity works patiently, drawing everything together, one atom at a time, one fragment of gas after another, until the vast emptiness gives birth to structure. But gravity doesn't only pull things inward. It also guides how things move as they fall, turning collapse into rotation, motion into balance, and chaos into harmony. Without gravity's gentle grip, the universe's eternal spinning dance could never have begun. In the earliest ages of the universe, after the first atoms formed from the cooling plasma of the Big Bang, vast clouds of hydrogen and helium filled the darkness. These clouds, spread across light years, were nearly still, yet within them existed small variations in density. Some regions were just slightly thicker, slightly heavier, and that was enough. Gravity began its slow work there, pulling the surrounding matter inward. The more matter gathered, the stronger the pull became, and soon, massive regions of gas began to collapse under their own weight. But here's where the story becomes beautifully complex. As these clouds fell inward, they didn't collapse straight down into a single point. Instead, they began to spin. The reason is simple but profound: the conservation of angular momentum. It's one of the most elegant principles in all of physics. When something begins to rotate, that rotation cannot simply vanish. It must be conserved. Imagine a figure skater drawing in their arms. As they spin, their body rotates faster because their momentum is preserved even as their shape changes. In space, the same law applies on a cosmic scale. As a gas cloud collapses under gravity, it shrinks dramatically in size, but the faint rotation it once had becomes amplified. What was once a slow, almost imperceptible drift becomes a whirling motion, accelerating as the cloud contracts, turning the pull of gravity into a graceful spin that will shape the destiny of worlds. That's how every star is born. A vast, diffuse cloud of gas, light years across, begins to collapse. At first, it moves slowly, almost silently, its temperature rising as gravity pulls matter toward the center. But as the cloud condenses, its rotation increases, flattening it into a disk. The central region grows hotter and denser until, finally, nuclear fusion ignites. A star is born, glowing with the light of creation. Around it, the leftover material continues to spin in the same direction, coalescing into planets, moons, and comets. Every orbit, every rotation, every day and night that follows, owes its existence to that first gravitational collapse. If you look at our own solar system, you can see the imprint of that original spin everywhere. The planets all orbit the sun in roughly the same plane and in the same direction. This is no coincidence. It's a direct inheritance from the spinning disk of gas and dust that surrounded the newborn sun more than 4.5 billion years ago. Gravity pulled the material inward, and conservation of momentum ensured it rotated. The result was a flattened disk, a cosmic carousel where tiny particles began colliding, sticking together, and growing into worlds. Each planet carries a fragment of that rotation, spinning on its axis, orbiting in rhythm with the rest. Even today, the motion of Earth, the turning of the moon, and the flow of comets are all echoes of that ancient spin set in motion by gravity's hand. The same principle applies on the grandest scales imaginable. Galaxies themselves, those sprawling collections of billions of stars formed when immense clouds of matter, stretching across millions of light years, began to collapse under their own gravity. The slight rotations that existed within those primordial clouds were amplified as they condensed, turning into the vast spiraling motions we see in the night sky. Each galaxy's graceful arms are shaped by the balance between gravity pulling inward and momentum pushing outward. Without that equilibrium, a galaxy would not be a disk of stars, but a chaotic jumble, collapsing endlessly into darkness. Gravity, rather than destroying structure, creates it through motion, sculpting stability from the very act of falling. And this process doesn't stop at stars or galaxies. Gravity continues its work even after stars live out their lives. When a massive star exhausts its fuel, gravity takes control again, collapsing the star's core inward. As it does, the same principle applies. Angular momentum is conserved, so the collapsing core spins faster and faster. This is how neutron stars and black holes come to rotate at unimaginable speeds, some spinning hundreds of times per second. These extreme remnants of stars are cosmic reminders of gravity's artistry, showing that even in death, the universe continues its eternal motion. To imagine this is to feel the universe breathe. Gravity is not just a force that pulls. It is the rhythm that guides. It takes something diffuse and formless and gives it purpose. The clouds that drift through interstellar space may seem idle, but within them lies potential, a slow gathering, a quiet tightening until the spin takes hold. The rotation that begins in the smallest whisper of motion grows into the defining movement of creation. Stars turn, planets form, galaxies swirl, all because gravity refuses to let stillness reign. In a way, gravity is both sculptor and conductor, shaping matter and leading its motion in perfect harmony. Every spiral galaxy, every orbiting moon, every rotating planet is a performance directed by this unseen hand. The universe is not merely falling, it is dancing. The collapse is never total, for gravity's pull is balanced by the outward push of momentum. That balance is the essence of spin, the quiet conversation between two cosmic forces that never ends. Even here on Earth, we feel gravity's pull constantly, holding us to the ground, keeping our oceans bound, guiding our moon as it circles us. But beneath that everyday experience lies the same universal law that governs galaxies and stars. The rotation of the Earth, the orbit of the planets, and the swirling of distant nebulae are all threads woven from the same fabric. Gravity's gentle yet unyielding embrace. It is the bridge between stillness and motion, between chaos and order, between creation and continuation. As the universe expands, gravity works tirelessly, forming stars and systems in the wake of that growth. Every collapse leads to a spin, every gathering of matter to a rotation. It is through this interplay that structure emerges, not by accident, but by the consistent, quiet application of the same timeless rule. Gravity teaches us that motion is not separate from stillness, that even as things fall, they turn, and through that turning, they find balance. The universe does not rush toward destruction, but folds into patterns, circles, and spirals that speak of enduring motion, of a cosmos held together not by chaos, but by the perfect, patient symmetry of its own invisible force. At the heart of every spinning planet, every orbiting moon, and every twirling galaxy lies a single, unbreakable principle: the conservation of angular momentum. This law is one of the most elegant and immutable truths in all of physics. It says that once something begins to spin, that spin cannot vanish on its own. The motion may change form, it may transfer or slow, but it never truly disappears. Like a secret rhythm woven into the universe's fabric, angular momentum ensures that the dance of motion continues forever. Imagine standing in a quiet room with a spinning top. The moment you set it in motion, it turns gracefully, balanced on its tip, carrying a small piece of the universe's eternal spin. It doesn't spin because of magic. It spins because energy has been given to it, energy that takes the form of angular momentum. As long as no outside force interferes, the top keeps rotating, its motion persistent and steady. The same principle that governs this small toy also governs the rotation of planets, the spin of stars, and the rotation of galaxies that stretch across the cosmos. The scale changes, but the rule remains the same. Motion, once begun, endures. In space, where friction is nearly non-existent, this rule becomes even more profound. There is nothing to slow motion, no air resistance or surface drag. When an object spins in the vacuum of space, it will continue spinning for eons. This is why the moon keeps turning around Earth, why Earth keeps revolving around the sun, and why galaxies continue to rotate billions of years after their birth. The conservation of angular momentum is not just a mathematical statement. It's a law that gives permanence to the universe's motion. To understand why, we can look deeper into what angular momentum really is. In simple terms, it is the measure of how much rotation an object has, how fast it spins, how far its mass is from its center, and how that motion interacts with the forces around it. When a system has angular momentum, that quantity cannot change unless acted upon by an external torque, which is a force that twists or turns. In the emptiness of space, where no such force is large enough to affect entire stars or galaxies easily, that momentum remains constant. The universe preserves its spin like a sacred memory, passing it down through every level of existence. This principle is what keeps the planets of our solar system moving in harmony. Billions of years ago, when the solar nebula, the vast disk of gas and dust that gave birth to the sun and its planets, was still forming, it carried a certain amount of angular momentum from its own rotation. As gravity pulled matter inward, the cloud flattened and began spinning faster, just as an ice skater does when pulling in their arms. The total angular momentum of that system never changed. It was merely redistributed. The sun, the planets, and even the smaller bodies, like moons and asteroids, inherited their portions of it, each moving in a way that balanced the total. The result is the organized, spinning system we live in today. If angular momentum could vanish, everything in the universe would slow to a halt. Planets would stop orbiting, stars would cease to turn, and galaxies would lose their structure. But that is impossible. The law of conservation forbids it. Even when forces act, collisions, explosions, collapses, the total amount of angular momentum within the system remains unchanged. It may be shared differently, transformed, or divided, but it is never lost. This is why, when two galaxies collide, they don't stop spinning. Instead, their spins merge, their stars swirl in new patterns, and their combined system continues to rotate, honoring the same universal rule. The beauty of this law lies in its simplicity and its universality. You can see it everywhere, from the rotation of distant stars to the spinning of a child's swing. When you twist on a swing and let go, you start to rotate slowly. If you pull your body in tightly, your rotation speeds up, not because a new force has appeared, but because your body's angular momentum must remain constant. The same physics that governs playgrounds governs pulsars, dense remnants of collapsed stars spinning hundreds of times per second. The forces at play are identical, only the scale and intensity differ. This conservation of spin is also what stabilizes the universe. Without it, the forces of gravity might have caused everything to collapse inwards endlessly, but the rotation provides balance. A planet spinning on its axis experiences a subtle outward force, centrifugal motion, that counteracts the inward pull of gravity. This balance creates equilibrium, shaping the flattened equatorial bulges of planets and maintaining the structure of galaxies. Every spinning object in the cosmos is engaged in this silent conversation between inward pull and outward momentum, a negotiation that keeps the universe from falling into stillness or chaos. The conservation of angular momentum also governs the lives and deaths of stars. When a massive star exhausts its nuclear fuel, it begins to collapse under its own gravity. As its core contracts, it spins faster and faster, conserving its angular momentum. The result can be astonishing. A once leisurely rotating star can become a neutron star, spinning hundreds of times every second, its surface moving at incredible speeds. Even as it shrinks and changes form, the total spin remains preserved, transformed, but never destroyed. This is why pulsars, those cosmic lighthouses, flash their beams in such perfect rhythm. They are the universe's most precise expressions of conservation in motion. Even on the smallest scales, the same principle holds true. Electrons, the tiny particles orbiting atomic nuclei, possess intrinsic angular momentum, what we call spin. This isn't spin in the literal sense, but it behaves as though it were, giving rise to magnetism, chemical bonding, and the fundamental properties of matter itself. The rule of conservation applies here too, guiding the behavior of the subatomic world just as it guides galaxies. It is a thread that connects every level of reality, binding the quantum and the cosmic together through the same eternal rule. To think of it another way, the conservation of angular momentum is like the heartbeat of the universe. It keeps everything in motion, ensures that energy and motion are never lost, and gives shape to the cosmos we inhabit. From the spiral arms of galaxies to the rotation of the smallest atom, every spin, every orbit, every cycle is a reflection of this law. The universe remembers its motion and refuses to let it fade. The stars keep turning, the planets keep revolving, and the great cosmic wheels continue to spin, because they must not by choice, but by the very nature of existence itself. When we look out into the universe, the first thing we notice is scale, vastness beyond comprehension. Yet, as our understanding deepens, we begin to see a surprising truth. The same patterns that govern the largest structures in existence also shape the smallest. The spiral arms of galaxies mirror the twisting structure of hurricanes, which in turn echo the coiling of seashells and even the molecular geometry of life itself. This repetition of form and motion across different scales is what physicists and philosophers alike refer to as the fractal nature of the universe. And within that fractal order, one particular motion repeats endlessly: rotation. From atoms to galaxies, the universe spins in self-similar harmony, each layer reflecting the motion of the next. The smallest building blocks of matter are themselves miniature worlds of rotation. Inside every atom, electrons dance around the nucleus, occupying shells defined not by physical orbits, but by probability zones of possibility where they might exist. While these electrons don't spin around the nucleus in the way planets circle a star, they still possess something we call intrinsic spin quantum property that defines their magnetic nature, their charge interactions, and even their identity. This spin is fundamental. It is not caused by movement through space, but is woven into the fabric of what an electron is. Without it, the universe as we know it would not exist. The chemistry of life depends on spin. Magnetic fields depend on spin. The behavior of light itself depends on spin. Even in the quantum darkness, where particles blink in and out of existence, rotation is already there, encoded in the laws of nature. If we travel upward in scale, from the invisible to the visible, we find rotation again, only now expressed in the behavior of celestial bodies. A planet's rotation defines its day, its climate, and its seasons. The tilt of its axis determines the rhythm of sunlight and shadow that governs every living thing. The moon's synchronized rotation, always showing the same face to Earth, is another subtle expression of this cosmic rhythm. Its orbit and spin are locked together by tidal forces, showing how rotation links objects across space in a delicate gravitational dance. And beyond planets, stars themselves are massive spheres of plasma that rotate ceaselessly. Their spin helps distribute heat and energy, influences the formation of magnetic fields, and affects how they evolve and die. When stars are born from clouds of gas, their rotation is inherited from the angular momentum of the collapsing cloud. When they die, that spin can be compressed into something unimaginably fast, as in the case of neutron stars or black holes. A collapsing core can go from spinning once every few days to hundreds of times per second, conserving angular momentum and amplifying the cosmic pattern of motion. When we move even higher to galaxies, the pattern repeats again. Every spiral galaxy we observe is a masterpiece of rotation. The Milky Way, our own galactic home, turns like a vast wheel in space, its stars orbiting the center at hundreds of kilometers per second. One full revolution of our galaxy takes about 230 million years. Yet the pattern of motion remains steady and elegant. The arms of the galaxy, rich with gas and dust, stretch out in spirals that mirror the swirls of hurricanes on Earth and the curves of water spiraling down a drain. The forces that shape them are different: gravity, pressure, angular momentum, but the geometry is the same. Across scales separated by billions of orders of magnitude, the universe repeats itself in form and motion. This fractal repetition tells us something profound about the unity of nature. It suggests that rotation is not a coincidence or a rare outcome, but a fundamental mode of organization. The same mathematics that describe the spin of an electron can, with modification, describe the orbit of a planet or the rotation of a galaxy. Patterns of rotation appear spontaneously whenever matter gathers, no matter the size of the system. It is as if the universe has one preferred rhythm, a kind of cosmic signature that repeats from the quantum scale to the cosmic web. The fractal nature of rotation also reveals how energy flows through the universe. In every rotating system, from atoms to galaxies, there exists balance attention between inward pull and outward momentum. This balance prevents collapse and creates structure. In an atom, the attraction between electrons and the nucleus is countered by quantum motion. In a star, the inward pull of gravity is balanced by outward pressure and rotation. In a galaxy, billions of stars orbit the center in a perfect compromise between gravitational attraction and centrifugal motion. The result is stability through movement, an eternal balancing act that keeps the universe alive and structured. Even the largest structures in the cosmos, galaxy clusters and superclusters, display hints of this rotational symmetry. Astronomers have observed that galaxies are not randomly oriented. They often spin in coherent directions, suggesting that the primordial motion of the universe left a vast imprint of spin across billions of light years. Some theories even propose that the entire universe itself might possess a faint, large-scale rotation, so subtle that we can only detect its fingerprints in the cosmic microwave background. If this is true, then the universe's spin is not confined to objects within it, it is part of space-time itself. A feature of the cosmos on the grandest imaginable scale, this fractal echo of spin appears not only in matter, but also in patterns of energy and motion around us. Weather systems on Earth rotate because of the same fundamental laws that shape galaxies. The Coriolis effect, caused by Earth's rotation, gives rise to cyclones and trade winds that spiral across the planet. The fluid dynamics of air, water, and plasma all obey equations that produce vortices and spirals. Whether you are looking at a storm from space, a swirl of cream in your coffee, or the majestic turn of a nebula through a telescope, the same mathematical story unfolds: rotation as nature's preferred language of motion. To see this unity is to glimpse the architecture of reality itself. The universe is not random chaos scattered across scales. It is a self-similar system, where patterns of movement and structure repeat endlessly, each level reflecting the one above and below it. Rotation is the thread that ties it all together, a sign that the same principles apply everywhere, from the smallest particles to the largest galaxies. The fractal nature of spin is a reminder that everything in existence is connected through motion, that the dance of the cosmos is not many separate dances, but one infinite choreography, unfolding across every scale of reality at the deepest level of existence. Beneath the visible patterns of stars and galaxies, beneath even the atomic structure of matter, there exists a mysterious domain where motion, energy, and information blur together, the quantum realm. In this strange arena, rotation does not simply describe how things move through space. It defines how they exist in the first place. The concept of spin in quantum mechanics, while often explained as a kind of rotation, is not physical spinning in the everyday sense. Instead, it is a fundamental property of particles, a hidden axis of orientation that connects their internal geometry to the flow of time itself. The deeper we study quantum spin, the more we uncover that rotation is not just a physical action, it is the language through which reality expresses itself. Quantum spin is one of the most mysterious aspects of physics, because it defies visualization. An electron, for instance, can be thought of as having a spin of 1/2. This means that it behaves as though it must rotate twice 720 degrees before returning to its original quantum state. Nothing in the classical world behaves this way. You can spin a globe or a wheel once, and it looks the same again. But a quantum particle requires 2 full turns to be identical. This unusual property points to a deeper symmetry embedded in the structure of space-time, a symmetry that is topological rather than geometric, hinting that the universe itself has hidden dimensions of rotation beyond what we can perceive. In quantum field theory, every type of particle corresponds to a field that permeates all of space, and each of these fields possesses its own form of spin. Bosons, like photons or gluons, have integer spins, meaning they can align perfectly and form coherent states such as laser light or the strong nuclear force that binds quarks together. Fermions, like electrons or protons, have half-integer spins, which follow the Pauli exclusion principle. No two can occupy the same quantum state at once. This simple rule, born from the mathematics of spin, is what gives rise to all structure in the universe. Without it, atoms would collapse into featureless lumps of energy, and the diversity of matter would vanish. Spin, in this way, is not a detail of particle physics. It is the scaffolding of existence. The rotational symmetries of quantum mechanics extend into the very fabric of time. Every rotation, whether in space or in abstract quantum states, carries with it a hidden oscillation that defines how a particle evolves through time. When two particles interact, their spins intertwine, creating entangled states that share a single rotational phase across vast distances. This is why an action on one particle can instantaneously affect its partner, no matter how far apart they are. The rotational symmetry of quantum states, therefore, not limited to physical motion. It weaves together space, time, and information into one continuous geometry. Time itself might be understood as a kind of rotational phenomenon. In relativity, space and time are two sides of the same continuum, but their relationship can be described mathematically as a rotation between spatial and temporal dimensions. When something moves through space, part of its motion is rotated into time. When it stands still, its motion through time dominates. This idea suggests that time is not linear, but cyclical, a dimension that turns continuously forward, much like a cosmic clockwork driven by the energy of the universe itself. If time has a rotational geometry, then every spin in the quantum world is not only a motion through space, but also a rhythm through time. This geometry becomes even more fascinating when viewed through the lens of quantum gravity and string theory. These frameworks propose that the smallest units of reality are not points, but vibrating loops or strings, each carrying angular momentum, a kind of spin at subatomic scales. The vibrations of these strings generate the particles we observe, while their rotations in extra dimensions determine the forces and interactions of the universe. Rotation, in this sense, is not something that happens within space-time. It creates space-time. The twisting and curling of these fundamental loops define the curvature of reality, the flow of energy, and even the passage of time. In the quantum vacuum, where particles flicker in and out of existence, spin continues to rule. Virtual particles, appearing for fractions of a second, always conserve angular momentum, the universal law of rotation that governs all interactions. This conservation law ensures balance at every level in an apparent emptiness. The vacuum is not still. It is a storm of rotational energy, a sea of spinning fields that underpin the solidity of the cosmos. When physicists talk about zero-point energy, the lowest possible energy state, they are referring to this restless rotational dance that never stops. Even when the universe is cold and empty, spin remains, whispering the rhythm of creation. The relationship between spin and magnetism further exposes the hidden geometry of the quantum world. The magnetic fields produced by electron spins are what make atoms bond, what make compasses point north, what allow planets to shield life from cosmic radiation. The magnetic polarity of the Earth, the sun's flares, and the spiral arms of galaxies all trace back to the same fundamental principle: rotating charge produces magnetic force. In this way, magnetism is the visible shadow of quantum spin on a cosmic scale, an echo of subatomic rotation projected into the macroscopic world. When we gaze into the night sky, we see an immense, silent panorama, stars glowing like eternal embers, planets drifting through the darkness, galaxies spiraling in elegant symmetry. But beneath that serene appearance, the universe is dancing. Every planet turns, every moon pirouettes, every galaxy whirls through space in a majestic rhythm of rotation. The cosmos is not still, it is alive with motion. Spin is not simply an outcome of physical laws. It is the unifying choreography that holds the universe together. From the smallest asteroid to the largest galaxy cluster, rotation governs balance, stability, and the very structure of the cosmos. Consider first the world beneath your feet. Earth rotates once every 24 hours, spinning steadily on its tilted axis. That rotation defines day and night, regulates temperature, drives the jet streams, and even influences the way life evolves. Without spin, the planet would be trapped in eternal daylight on one side and unending darkness on the other. The rotation generates a centrifugal balance that slightly flattens the poles and bulges the equator, creating the Earth's true shape, an oblate spheroid. But this rotation also gives rise to the Coriolis effect, bending winds and ocean currents, forming hurricanes and trade winds, guiding the global climate system that sustains life. Every cloud formation, every ocean wave, every gust of wind owes something to the spin of our world. Now expand that view outward to our solar system. Every planet, from the scorched surface of Mercury to the icy reaches of Neptune, carries the imprint of rotation. Each spins at its own pace. Jupiter in under 10 hours, Venus in 243 Earth days, Uranus rolling sideways like a cosmic barrel. These differences in rotation reveal the story of their formation, shaped by collisions, magnetic interactions, and gravitational tides. The angular momentum inherited from the solar nebula, that spinning cloud of gas and dust from which the sun and planets formed, ensures that each planet maintains its unique rhythm. Even the sun itself rotates, completing a turn roughly every 27 days near its equator. Its spin creates magnetic fields that twist and snap, generating solar flares and coronal mass ejections that ripple through the solar system and influence Earth's auroras and communication networks. Spin also determines the existence of moons and rings. The Earth's moon, tidally locked, spins at just the right speed to always show us the same face, a perfect synchronization born from billions of years of gravitational interplay. Saturn's rings, composed of ice and rock fragments, whirl in perfect balance, each particle maintaining its orbit through the delicate dance of centrifugal force and gravity. The tilt of Saturn's axis, like Earth's, ensures that its rings catch sunlight in different ways throughout its long seasons, producing breathtaking changes, visible even from telescopes on Earth. Everywhere we look, the balance of spin and gravity sculpts both beauty and order. Beyond our solar system, spin shapes the very architecture of galaxies. Our own Milky Way is a vast spiral, its arms curling outward in graceful arcs. It rotates once every 230 million years, carrying our Sun and all its planets on a vast cosmic journey around the galactic center. At that center lies a supermassive black hole, Sagittarius, rotating at nearly the speed of light. Its immense spin warps space-time itself, dragging surrounding gas and dust into a luminous whirlpool that feeds its energy. This galactic spin stabilizes the structure of the Milky Way, preventing collapse and maintaining the balance between gravitational attraction and centrifugal expansion. Each star, each planet, and even each interstellar cloud moves in harmony within this grand spiral motion. Spin, in the cosmic sense, is also the universe's stabilizer. Without it, celestial bodies would not form as we know them. A planet that did not rotate would experience extreme conditions: a scorched hemisphere and a frozen one. A galaxy without rotation would collapse under its own gravity, forming a featureless sphere. Rotation prevents this fate by creating centrifugal force, counteracting gravity's inward pull. It spreads matter outward, distributes energy, and allows systems to find equilibrium. In this way, spin is not merely motion, it is balance. It is the cosmic counterweight that allows structure to persist amid the pull of collapse. In the life of stars, rotation plays a role just as vital. When a star forms from a collapsing cloud of gas, it inherits spin from that motion. The faster it spins, the more its magnetic fields intensify. These fields drive stellar winds, influence sunspots, and shape the star's outer layers. As a star ages, it loses angular momentum through these winds, gradually slowing down. But when it dies, when gravity overcomes its outward pressure, its remaining spin can dictate its final form. A slowly rotating star may quietly fade into a white dwarf. A rapidly rotating one may explode as a supernova, collapsing into a neutron star or black hole. whose rotational energy can power some of the most energetic phenomena in the universe, including gamma-ray bursts and relativistic jets that shoot across galaxies. Rotation also gives rise to the phenomenon of precession, a slow wobble in a spinning object's axis. Earth experiences this too, tracing a slow, circular path in the sky every 26,000 years. This wobble affects the timing of the seasons and the alignment of constellations, reminding us that even our planet's spin is dynamic, not fixed. On a cosmic scale, entire galaxies precess due to gravitational interactions, their axes shifting like dancers weaving around one another. These subtle changes contribute to the evolving structure of the universe, influencing where stars form, how clusters merge, and how galaxies interact over billions of years. Even dark matter and dark energy, the invisible forces that dominate the universe, may carry hidden spin-related properties. Some theories propose that dark matter particles could have intrinsic angular momentum, subtly influencing the rotational curves of galaxies. The mysterious acceleration of cosmic expansion might also connect to the rotational energy of space-time itself, a vast, unseen whirlpool driving the universe's evolution. Though these ideas remain theoretical, they emphasize one truth: rotation is not confined to what we see. It operates in dimensions and domains far beyond our perception. At the grandest scale, the cosmic web itself, the network of filaments and voids that make up the large-scale structure of the universe, shows signs of rotation. Galaxies within filaments seem to align their spins with these vast cosmic threads, as if the universe itself were twisting on unimaginable scales. This global rotation is subtle, but it may be the fingerprint of the original spin born in the Big Bang. It suggests that even across billions of light years, the same laws that make a child spinning top dance are at play, unbroken and eternal. Spin is therefore not just a mechanical property, it is the foundation of cosmic harmony. Every orbit, every magnetic field, every gravitational balance arises from it. Rotation shapes matter, regulates energy, and choreographs the grand dance of the cosmos. From the turning of electrons to the spiraling of galaxies, spin weaves a universal symmetry that connects the microscopic with the majestic, the quantum with the cosmic. It is the rhythm of existence itself, the ceaseless dance that keeps the universe alive with motion and meaning. If you could silence the stars, still the planets, and hold every atom in the cosmos perfectly still, would the universe itself finally rest? The answer, in physics and philosophy alike, is no. The universe cannot stop spinning, because spin is not merely a movement, it is existence itself. From the first ripple of the Big Bang to the whirling of galaxies billions of years later, rotation has been the constant heartbeat of creation. Everything that exists carries angular momentum, and even as forms change, collapse, or die, that momentum never disappears. It is redistributed, conserved, and reborn across the endless cycles of cosmic evolution. Spin is the one thing that endures when everything else fades away. At the heart of this eternal motion lies one of the most fundamental principles in physics, the conservation of angular momentum. This law dictates that once rotation begins, it can never end unless an opposing force cancels it out. In the early universe, there was no such opposing force strong enough to still the motion. As matter formed and scattered, the initial imbalances of energy and mass created vortices of motion that became self-sustaining. Even as galaxies collide, stars explode, or planets are shattered, the total angular momentum of the system remains constant. It is transformed, transferred, and redefined, but it never truly vanishes. The universe, in its grand unfolding, is bound by this immutable law to turn forever. Consider a dying star collapsing under its own gravity. As its core contracts, its spin increases dramatically, just as a figure skater spins faster by drawing in their arms. This process gives birth to neutron stars, tiny, dense remnants that can rotate hundreds of times per second, and black holes, which can spin at nearly the speed of light. Even as the star itself disappears from view, its rotation persists, encoded in the fabric of spacetime. Around spinning black holes, space itself begins to twist, a phenomenon known as frame dragging. In these regions, rotation becomes inseparable from the geometry of the cosmos. Space and time themselves are forced to swirl in endless motion. Even when light cannot escape, spin remains, etching its momentum into the curvature of the universe. This continuity of rotation is also evident in the evolution of galaxies. When two galaxies merge, their individual spins don't cancel each other out, they combine, creating new axes of motion. The resulting system may seem chaotic for millions of years, yet, through gravitational interactions, the angular momentum redistributes until a new equilibrium emerges, a new cosmic dance. In this way, rotation acts as the universe's self-regulating mechanism, ensuring that chaos gives birth to order once again. Each collision, each explosion, and each collapse contributes to the unbroken chain of motion that stretches across cosmic history. Even on the smallest scales, spin never ceases. Within atoms, electrons continue their quantum rotations, defining the behavior of elements and molecules. The spin of particles generates magnetism, allowing for chemistry, electricity, and ultimately life itself. This microscopic motion is not separate from the spinning of galaxies. It is its mirror image. The same mathematical principles describe both. Spin links the very large and the very small, uniting the cosmic and the quantum in one continuous spectrum of motion. To stop spin would mean breaking the symmetry of nature, and the universe does not allow such stillness. The cosmic background radiation, the afterglow of the Big Bang, also carries evidence of this perpetual rotation. Subtle anisotropies, minute differences in temperature and direction, reveal traces of the universe's primordial angular momentum. These faint signatures are like the fossilized tracks of an ancient spin, preserved in the light that has been traveling for over 13 billion years. The fact that we can still detect these imprints means that the motion from the universe's infancy continues to influence its shape today. Galaxies, stars, and planets are not isolated objects spinning in emptiness. They are part of a single, continuous flow of momentum that began at the dawn of time. The question then arises, could the universe as a whole be spinning? Some cosmologists have explored this possibility, proposing that the entire cosmos might have a global angular momentum, a vast rotation imperceptible on human timescales, but encoded in the orientation of galaxies and the polarization of light. If this is true, then every turn of every particle is a small part of that grand cosmic rotation, a collective motion of the universe itself, winding through eternity. Even if the overall spin is immeasurably slow, the concept suggests that motion is not a property within the universe. Motion is the universe. Spin is also deeply tied to the arrow of time. The direction in which things rotate, decay, or expand defines temporal flow. If time is the forward march of entropy, then spin is the physical manifestation of that progression. Every rotation marks a passage. The turning of planets creates days, the orbit of Earth makes years, and the spin of galaxies measures the epochs of cosmic history. In this sense, spin is the metronome of time, measuring not just movement but existence itself. Without it, time would lose its rhythm, and the universe would freeze into a lifeless, timeless void. The persistence of spin even extends into the far future. Trillions of years from now, when stars have burned out and galaxies have drifted apart, rotation will remain. Black holes, though they may eventually evaporate through Hawking radiation, will release their stored angular momentum back into the fabric of space as gravitational waves, ripples of spinning energy that carry momentum to infinity. These waves will continue to move through the darkness, spreading the last whispers of motion across the cosmos. The universe may cool, fade, and thin out, but it will never come to rest. Its final state will not be stillness, but a quiet sea of eternal rotation, where every wave, every vibration, and every quantum field continues to spin in silence. Even in the philosophical sense, spin represents the continuity of existence. It is the symbol of cycles: birth and death, creation and decay, expansion and collapse. From the spiral of a hurricane to the orbit of a moon, from the DNA helix in our cells to the swirling arms of galaxies, rotation reflects the natural order of becoming. Everything turns, because everything transforms. Motion is not an accident. It is the mechanism of persistence. To move is to be, and to spin is to endure. When viewed through this lens, the universe becomes not a machine winding down, but a vast, self-sustaining vortex of energy, a timeless current of motion that recycles its angular momentum across scales and eras. Every rotation feeds another, every death gives rise to new spin, and every spin gives structure to new life. If the universe were ever to stop spinning, it would mean the end of time, the end of existence, and the collapse of reality itself. Yet such stillness can never be achieved, because rotation is woven into the essence of being. Even the fabric of space-time carries angular momentum. The curvature of the cosmos, the bending of light, the warping of gravity, the expansion of the universe, all are manifestations of hidden rotations. Every photon that travels through the universe carries spin. Every vibration of an atom contains angular momentum, and every gravitational wave that ripples through the cosmos transmits a rotational pulse born from colossal events. This eternal spin is also a reminder that the universe is not linear. It is cyclical. Energy transforms but never disappears. Motion changes form but never stops. Stars die, but their spin becomes the energy of black holes. Black holes decay, releasing rotational energy as gravitational waves that stir new regions of space into motion. Even as galaxies drift apart in the accelerating expansion of the universe, their residual spin ensures that the cosmic story continues. The universe endures because it turns. And as long as it turns, it lives in the end. The mystery of why everything in the universe is spinning brings us face to face with one profound realization. Motion is not a side effect of creation. It is creation itself. From the first stirrings of energy after the Big Bang to the orbits of planets and the rotations of atoms, every corner of the cosmos is engaged in a timeless dance. As we look deeper into the heavens and deeper into ourselves, we find that we too are part of this great rotation. The atoms that form our bodies once belonged to spinning stars. The energy that fuels our hearts is born from ancient cycles of motion. Every breath, every heartbeat, every orbit of the planet beneath our feet echoes the same eternal law. Everything moves, everything turns, everything flows, and so, the next time you look up at the stars, remember that you are not merely watching the universe move, you are witnessing its memory, its rhythm, its never-ending spin. From galaxies swirling in silence to the quantum particles vibrating beneath your skin, the universe reminds us that existence is not static, but endlessly dynamic. To spin is to live, to turn is to endure, and through motion, the cosmos continues its infinite song. The dance that never truly ends. Good night.